Hi everyone, a very good afternoon to each one of you joining our today's webinar on microservices, basics and beyond. This is going to be an interactive and instructor-led webinar, and we have Anurag Yadav with us as our speaker. To begin with, I would like to share a brief introduction about Anurag. So Anurag is a core techie at heart and a Google certified cloud architect who brings over 2 decades of rich experience in architecting and engineering large scale distributed systems and software products. He has a deep expertise in microservices, relational and non relational databases, cloud, and related technologies. So, without wasting any further time, I'll be giving the floor to Anurag. Anurag, over to you.
Thank you, Anamika. Is my voice audible?
Yes, it is.
Okay, great. And I'm not sure if you can see my screen right now. Okay, and I think I should be on the video right now.
Yeah, so
And
we can see you, but your screen is not visible yet.
yes, I'm just sharing that.
Yeah, it is.
Okay, great. So, hello everyone. This is Anurag. Anamika has already introduced me. So, thank you, Anamika. So, what we are going to do is we are directly going to jump into this topic because we have lots of topics to cover over here. We have just 2 hours. So let's first start with what is the topic at hand we have. So what we are going to discuss over here is microservices, and we are going to discuss why we do microservices and how do we do microservices. So if we have to develop microservices, how do we develop? And we are going to see how we can develop it using Java and Spring Boot technologies. Okay. So let's first set the context. So when we say microservices or services, where do they lie in the whole system? So this is our user interface, and this is the first thing that user interacts with, and then requests go to services. And here I have shown some microservices. We can have service-oriented architecture also over here, or a monolithic service. Doesn't matter what I'm trying to say over here. We'll have some services over here, and then later we will have our databases. It can be one database or multiple databases, and that can be backed by a data warehouse for reporting purposes. So what we are going to talk about is in this section. So before we start with microservices, let's just turn our attention to what are the objectives of doing microservices. And then we'll go into what microservices are. So these are the objectives as you can see on the screen. So some of them are development related objectives. So let's say it should be highly scalable. This is something that development team is responsible for that. And then we should be able to do independent development. That's another objective. Once we are able to develop it independently, we should be able to deploy our solution independently. And once we are able to deploy it independently, we should be able to frequently deploy it. So these are the two goals that primarily operations team is responsible for. And the first two goals is something that development team is responsible for. Ultimately, the whole team under DevOps is responsible for achieving these goals. But these are the goals for microservices. Now, microservices, as you might know, they became quite popular after year 2010. And this was along with the rise of DevOps with CI, CD and all that stuff. So microservices has a relation with that, how it has evolved and what its purpose is. Now, let's get into this, what a service is, and then we will get into what different kind of services are. So a service is basically a part of a business application. So a business application has got some business logic, and usually what we do is we separate the presentation layer. Generally these days it is web app. We separate it from the application and we host business logic in a separate application called business service. Now this business service has got programmatic interface. It's not an interface that is useful, much useful for humans, although we can uh, interact with that too. But it is primarily designed for application interaction. So we make this separation between our user interface layer, web application, and the business service. So when I say service, this is what I mean by service.
Anurag, we have a question in the chat by Abhijit Das.
Okay,
Um, who was
let
the
me just
predecessor
see.
of microservices and what was the motivation behind choosing them?
Okay, so we are going to come to that. So and most
Particularly
of
in
the
the wake of common
questions.
goals in both. So it's written in the chat portal.
Okay, let me just open that. If I understand the question correctly, um, okay. Okay, so we are going to discuss that. I think if something remain unanswered, we will try to address that at the end of the session. But this is something that anyway I'm going to come to. It seems my computer, there's a little hang over there because of this window. I'll just try to close it. Okay, I think it's gone. Sorry about that. So, okay. So yeah, Anamika, so what we'll try to do is, I think this is creating some sort of problem for me when I'm opening my chat window. My computer hung for some time. So mostly what I'll try to do is, if there is not something very critical, then I'll try to address it at the end of the presentation. And what that will do is, hopefully many questions will anyway get answered during the flow of the presentation. So we will try to address these questions at the end of the presentation. Okay, so
We will have a 10 to 15 minutes of Q&A at the end of the session as well. So, and also I'll keep a track record of the questions being asked. So if it's not
sure,
answered as suggested in the session, or that will be answered at the end of the session.
thank you.
Yeah.
Okay, so we discussed about service, time to move to monolithic services. So monolithic services have been there for very long time. They have been there since 1980, and they have been the popular way of developing application till year 2000. And these are just rough years. Don't take it as the year when some event happened. It's not like that. I'm just trying to give you an idea when a particular technology was popular. So monolithic services, uh, during these times, 1980 to 2000, these were generally business applications. There was no internet traffic. So these applications uh, did not have many users. So scalability was not such a big problem. The big challenge over here was functionality. So these applications architecture was designed to address functionality. So that was the main challenge at that point in time. So these monolithic application, what they would have or they used to have is that they will be divided into logical components. Let's say they'll have an app interface. This will be the interface through which other applications can interact with them. It will have a business logic layer, which is its core layer, and which will have all the modules. And the goal always used to be to design these modules loosely coupled and highly cohesive. in order to keep the code maintainable. And for similar reasons, we have a separate data access layer to interact with database. Now, these were monolithic services. Everything was fine till traffic was not huge. Then what happened was, as the traffic increased and then there were requirements for integration, this was not a great architecture. And it wasn't that maintainable either. The reason was, although the goal was to design loosely coupled and highly cohesive modules, but there was nothing to guarantee that. So only when, let's say, you go to fix a bug or you are upgrading the application with a new feature, that's when you will realize that your modules are not really coupled. So this did not guarantee the loose coupling and high cohesion, those design principles with which we design our classes or our modules. Now, if you have to uh, develop and test it at scale, so let's say there is an issue. Now, issue is in, let's say, product uh, module. If we have to fix this issue, then because there is no guarantee that the issue would not have affected other modules, because there is no way to guarantee loose coupling and high cohesion. So what we'll have to do is we'll have to rebuild and test and deploy the entire application. So that's a very costly thing to do. And if the business logic is complex, then testing the entire application is a difficult thing to do. So that was one big challenge with monolithic services. The other challenge was due to scale. Now imagine if the number of users grow for this application. The typical solution was this, that we would host more instances of this monolithic application. So let's say right now we had one, we have added second and third instances, and maybe we can have a reverse proxy or a load balancer in between, and we can balance the load like that. So now we have three instances to cater to user load. So that way we can take care of the load that goes up. But this is not a great way of scaling. The reason is that till you have to, let's say, host 5, 6 instances, then any inefficiencies in hosting is not going to hurt us. But imagine if we have to host 1,000 instances, then any inefficiency is going to hurt us. And I'll tell you now what is the inefficiency over here. The inefficiency is, let's say, let's take the case where this is an e-commerce system, as you would have guessed. So users are looking for products, they are browsing for products. Now they are looking at the details of the products, maybe looking at their feedback, but they're not actually buying the product. So the load on, let's say, orders service or inventory service, it's not that high. The load is actually high only on product service, and let's assume that it's very, very high. Now, just to scale the load, to cater the load for product module, because this whole application is one bundle, we'll have to scale the entire application. If we could have somehow separated these modules into separate services, we would have just scaled product service. But over here, because everything is bundled into one solution, one application, we will have to uh, replicate the entire application. What that means is this will consume more CPU, unnecessary CPU, right? And because now we are replicating the entire application, and the memory that it will consume, each instance will consume, will be the requirement of the entire application. And then this will lead to more number of instances, more disk space. So this is not something that will scale very well for a large scale application. So monolithic architecture is good if you are starting with, let's say you are a startup, you are doing a prototype, it's a good model to start with, but we know this, that this is not going to scale. So this was the problem with monolithic services. So this was very clear as internet grew and there was more traffic, more number of users, and applications became more consumer facing. So there was a need to break monolithic services into smaller services so that we can scale them differently as we discussed. So this was one reason where we wanted to create more services, and then there was a need to integrate them, because if they are not integrated, they won't work together. We can't have a single solution. So there was a need for multiple services and need for integration of these services. And then we were also trying to make composite applications by combining various services into a single application. So let's say there is a company, it takes over, or there is a merger with another company. And the idea is that they will bring their two solutions together and they will create a bigger solution which can address a larger market with a larger scope of problem. So in this way, this was another reason why we needed to integrate applications. Doesn't matter, there can be more reasons also. These were the main reasons why we would like to uh, integrate applications. And the key aspect when we are going to do service integration or integration of application is we'll have to work with interoperable interfaces. The other thing is that we'll have to decide on integration architecture. And the two integration architecture choices that we have today, they are service oriented architecture and microservices architecture. So this is something that we are going to discuss in our next few slides. So let's first look at service oriented architecture, and which came in the year 2000. Somewhere during this time it became popular and there were a lot of implementation between year 2000 and 2010. Again, this is not an hard and fast range of time, but just to give you some idea. So let's move to the next slide, where we will first discuss interoperable interfaces and integration architecture, and then we will move to service oriented architecture. So what interoperable interfaces do we have? So in the beginning of 2000, we had SOAP. And at that time, actually, we also had REST, although REST wasn't that popular, but SOAP was the main interface of choice for enterprises, uh, companies which sell business software, the kind of software I described earlier. So let's say banking software, supply chain management software, CRM, ERP, those kind of. So here the SOAP was pretty popular, and the reason was that SOAP provided this WSDL contract. So WSDL is nothing. It's an interface that you can define. And this interface will tell you what are the functions that a service has got, and what are the messages and that can be passed to these functions, and what kind of response can be expected from these services. So this interface was that. So this interface we can think of as a class interface, right? Just one second. Okay, I'm not sure if my voice is audible right now. Is it? Okay. In between, if there is any question, let's say I'm going to finish this slide and I'm going to stop for any question that you may have, and then we will go to service oriented architecture. Okay, so we were at WSDL right now. So this WSDL we said is like class interface, right? So here we will have functions, and we will know that what messages it can accept and what it can return back. So this SOAP is something which conforms to a particular interface, and this is good for enterprises because they want clarity. So let's say an order is coming from one department to the other department, or from one organization to other organization. So they want a certain structure. So that structure was forced through WSDL, and we could generate clients called stubs and server-side clients called skeletons, which can convert SOAP requests into native objects. So let's say client is a Java client and the SOAP communication is happening using XML because that's the format of SOAP. So the conversion between Java objects and XML will be done by these stubs. So this was good uh, because we get stubs uh, just by generating them, and we'll not have to write code. Okay. So, but the issue over here is that it results into tight coupling. What that means is that if we change the interface a bit, right, that will mean that we'll have to generate these stubs and skeleton once again. And that will mean that we'll have to change client and service code. So that results in tight coupling, and that prevents in scaling the solution, scaling in the sense that let's say if we want to deploy a solution, if there is a change to the interface, then we'll have to change the clients. And that will mean we cannot deploy it without changing the clients. So that's something that we wanted to change. And that was something which was available with REST because REST did not mandate any use of interface. REST is free of interface. Uh, there, if the message is wrong, that will be detected only at the runtime. There is no compile time check. So that gives us some loose coupling. We do lose this flexibility of getting clients generated, but that is not needed because we can use HTTP libraries and pretty much every runtime. So let's say Java or C++, it can be anything, or for that matter, JavaScript, they will have HTTP clients. So they can easily uh, they can easily use HTTP clients to make requests. Now, the next thing over here is the architecture for integration. SOA preferred a neat architecture using ESB, wherein every service will interact with ESB and ESB will take the responsibility of passing the messages between services. And there is another decentralized approach, which is followed by microservices. In this, each microservice is responsible for connecting to the service it wants to connect to. So let's say service one wants to send a message to service seven, it will directly connect to that. And if any transformation of messages is required, it will be done by service one. And similarly, when service seven responds back, any transformation that is required will be done by service seven. So we will discuss this as we go to service oriented architecture. But at this point, let me just check if there are any questions. I'll like to open my chat box and let me, Anamika, we can do one thing. We can open the session, let's say for a few minutes. And if there is any critical question, I may answer that right now.
Sure. So for now only we had this one question that was by Abhijit, listed earlier, who was the predecessor of microservices, which you saw. So maybe you can address it to him.
Okay, so Abhijit, are you there?
Yeah, so he's actually, everybody's on auto mute, so they'll be able to connect with you through the chat so that we can
Okay,
avoid background noises.
so I think I can read Abhijit's question. So Abhijit is asking, doesn't ESB also overlap with decentralized mechanism in microservices? Any important distinction there? Okay, um, I'll try to answer this question. So microservices actually do not recommend use of ESB because we will discuss this, why it doesn't recommend that. And this centralized architecture is something that is specific to SOA. SOA, in fact, recommends centralized architecture, and it's an important thing in SOA to keep services loosely coupled, and so that these service developers, they don't have to worry about integrating applications. In microservices, we do not have such thing. So you are asking, doesn't ESB also overlap with decentralized mechanism in microservices. So if you are having, let's say, ESB, then you won't do this decentralized communication, because the whole point of having an ESB is that you can do this centralized communication, so that every message can pass through ESB. So you do not want decentralized communication with SOA. I hope that that answers the question. Abhijit?
I see Snehal has
Okay.
also raised her hand.
Okay.
Snehal, if you have any question, please mention it in chat. Sir will be answering it.
Okay. Great. So Abhijit's question is answered. So Anamika, what I'll do is, in the meantime, I'll move to one or two slides more, and after SOA or microservices slide, then I can take up the next question. Is that okay?
Sure, sure. If something comes across, I'll let you know. So till
Okay.
then, you may. Yeah, thank
Okay.
you.
So you can interrupt me anytime.
Great.
Okay. Thank you. So now let's move to the next slide. I'm sorry, something. Okay. Okay. I move to the next slide. It's so something happens to my system when I open chat window, but I think we'll manage. Not a problem. Okay. So so we said so far that monolithic services were a problem, and we said that service-oriented architecture and microservices could be a solution. So now let's first look at service-oriented architecture, which became popular during 2000, and it was quite popular till year 2010, and microservices came afterwards, meaning they became popular afterwards, although microservices were being implemented much before than that, but they became popular after that. Okay, so the gains that we made with service oriented architecture is, I'm sorry, I think I'll have to go back. Okay, yeah, let me, okay, we are good. So we were able to make our services modular. Now we can scale these service differently. That was one thing we solved with this microservices architecture. And for integration, we were using SOAP, which was an interoperable interface. Now, what that means is that, let's say if I have this order service as a Java service, and this inventory service, let's say for some reason it's a C++ service. Now, in a monolithic application, I could not have that. But with service oriented architecture or SOAP, it allowed me to make a call from Java to C++. Now, this is something that we could have achieved with Corba also, but these were not very visible interfaces, so they were not that popular. SOAP became popular because it was XML. We can see that operate protocols like IIOP or Corba, they were binary. They were not popular because we could not see the messages, although they gave high performance. But SOAP became the main protocol for integration. So because our services were interoperable, we could reuse, let's say, C++ code with uh, Java code. So there are many more examples. I mean, we can have any technology that supports SOAP. So we can do stuff like that. Now, the other thing that is possible over here is that, which kind of I already mentioned, that now it was possible to use different technology stack, libraries, and frameworks within the same solution. Within monolithic system, it is not possible. If we are doing our application in Java, it will be all in Java. So let's say some service we want to develop in using JavaScript on node.js. So that was not possible with monolithic application. The other thing is, it's not to do with the architecture per se, but it was recommended that do stateless services so that we can scale them. Now, if services are stateful, they cannot be scaled well, but if they are stateless, they can be scaled. So this was something that was proposed by service-oriented architecture. Now, these were the gains that we made as part of service-oriented architecture. So now let's see what was the issue with service-oriented architecture. Now, the issue with service-oriented architecture uh, was this, that it had this common schema, XML schema. So this schema was common between all these services within the system. So if there was any change in the schema, the all these services, they used to get affected, which means we'll have to test all these services. So which means that we are not achieving our goal of independently deploying our solution. So let's say if there is a problem with inventory service, and for that, if we had to made any change with XML schema, then that will affect our order service. So when we are patching or deploying our inventory service, we'll also have to deploy order service. And possibly we'll also have to deploy product service after testing it, because these are now related, they are coupled with each other. The other kind of coupling comes from the schema. All these services, they share a schema, they share a database, and they often, in order to do transactions, in order to do asset transaction, they can look into these tables. Some of them can be integration tables, or some of them can be tables owned by other services. The point I'm trying to make is that because they use each other's tables, because there is a common database that is available, that database couples these services. So if anytime we are making changes to this schema, because there is problem in one service, that can actually affect other services. And that would mean that we'll not be able to release our solution or deploy our solution without testing the whole solution. So this solution is, we do have some advantages, like we talked in the previous slide, but we can see this, that this is a tightly coupled solution in many ways because of schema, uh, front schema, XML schema, and the backend schema. So it's not a loosely coupled solution, and deployment is not flexible because of that. Other problem is SOAP is not a protocol which is highly suitable for mobile and JavaScript applications. Now, if you compare it with REST, REST works with HTTP clients, and all of these mobile application and JavaScript clients, they have HTTP clients, so they can easily and quickly make calls to RESTful interface, but they can't do that with SOAP interface, because with SOAP, they will need stubs on mobile and JavaScript applications, those client libraries, SOAP libraries, to make a call to SOAP service. So it's not a very popular thing for mobile and JavaScript application. The other thing is, like we discussed before, it requires, it recommends the use of ESB. What is done in ESB is when messages are passed around, these messages can be routed to the right service, and that is something ESB can take care of. We can configure ESB for that. ESB, we can write adapters within ESB. It can transform messages. We can define business rules. We can make workflows. We can even do centralized monitoring in ESB. So all that is good if we do not have a lot of load, but this is not something good when we have a lot of load. I think I have next slide, and I'll discuss the same point over there. So briefly, the point is that this ESB becomes overloaded once we have a lot of services, and this itself becomes a bottleneck, and this cannot be scaled. So my service probably they can be scaled, but now ESB becomes a bottleneck, and this cannot be scaled. So that's a problem. So this ESB use, it promotes centralization of functionality, adapter functionality, whatever light functionality that is, it is getting centralized, and it becomes bottlenecks in test and development, because if there is any change in service interaction, will have to go to ESB developers that look, there's the change, and you'll have to implement that change. So this is the kind of bottleneck that ESB presents. And this is something that microservices they try to solve. Now, why do we have this bottleneck in ESB? Because if let's say we are not doing ESB, we are not doing this centralized architecture, we are doing decentralized architecture, then our services will have to approach other services directly. Now, ESB, what it says to us is that you just need to deal with ESB so that the client service gets totally decoupled with the service which is actually serving the request. So let's say service one has to call service six. It doesn't need to know about where service six is located. Where is the endpoint for service six? Whether it is even service six also, that also service one doesn't need to know. And that is something that will be hidden from service one. It will be taken care by ESP. So there will be a lot less load in terms of configuration on services. But the problem with this architecture is that somebody has to configure these routings, right? So let's say service 3 has to make a call to service 6 and service 8. So somebody has to do this configuration. And this is something that ESB developers or people who are responsible for configuring ESB, they are doing. And once we have lots and lots of services, this ESB becomes a big piece in itself. If we have small number of services, this integration is small and everything works fine. But what happens if we have large number of services to be integrated? Now this integration itself has become a big piece, and it has become such a big piece that we now like to break it down, because we said that if we have to scale something, we should break it down. And that is why we were doing service oriented architecture. We have broken down our services into smaller services. And here we created something which is not smaller. It is growing bigger and bigger as we are adding more services. So this piece became complex and it was hard to scale. So that's where this microservices decentralized architecture, it looked very superior. So this is one big reason. Today, if you do not want to do service oriented architecture, this is one reason you would not like to do it. And of course, I didn't tell this that this ESB comes at a great cost. So this is generally bought by enterprise company. They have lots of money, so they can afford this kind of stuff. But let's say if you are a new company, you are only mainly working from open source through open source. This is not something that you would like to buy. So service oriented architecture has many advantages over monoliths, but it is still has some issues. Now, I did not directly compare microservices with monolith because we also have this option of service oriented architecture. So in some certain cases where you are an enterprise and you do want a tight coupling of interface and you do not have scalability issues and you can work with ESP, that may be a great solution for you. But if you are a startup or you are a company, you're making a product which is going to take up a lot of load, it is a consumer facing application, then that may not be a great architecture. So this is my last slide on explaining what microservices are and why are we doing this. Once I finish this, I will see if there are any questions. If not, then we will move to the demonstration. Okay, so here we have seen that microservices, they resulted in tight coupling, but not microservices, sorry, service oriented architecture. So microservices, what they recommended is that you partition your solution vertically. So partition your solution in business domain and partition it such that they do not have any common front end schema. So they do not have any common WSDL or XSD, like service oriented architecture or SOAP services have use a loosely coupled communication interface like REST, which does not mandate that kind of coupling. So that way you can have these loosely coupled services. And the other thing that it recommends is that if your services are like they you find them in real world also that the way business works is that they are totally decoupled. So let's say if you go to any big company, their product department is separate, their order department is separate, their inventory department is separate. So they anyway work in a manner where they are loosely coupled. They do not have tightly coupled interactions with each other. And that's where having a separate database makes sense, because we are not going to do transactions across these transactions or domain boundaries. So that way we can have these independent DB. What that means is these services are completely independent of each other. So due to this vertical partitioning, because we are using REST interface and independent schema, what we get is we have a shared nothing architecture where there is nothing shared between, let's say, inventory service, this particular domain, and there's nothing shared between order service and product, and vice versa. So the only way they can communicate is through the front end, and that to a loosely coupled uh, interface, REST interface. So with this shared nothing architecture, what we get is we get extreme scalability. So if we have to, let's say, scale inventory, or let's go to product, that's where we said that there can be a lot of load. So we can just keep on adding instances to our microservice. And let's say I have added thousands of instances to this, and these services are working. Let's say order services working with 10 instances, inventory services also working with 10 instances, and in product service, I have 1,000 instances. Now, this is important over here that I can have 1,000 instances over here because my database is separate. Now, the load that these 1,000 instances they are creating, they are only creating on product service. So something has to be done in order to handle that load at database end. That will have to be done only at product end. We don't have to touch order database or inventory database. So the scalability of this product service is totally independent of inventory service or order service. So scalability becomes totally independent. We can scale them extremely. And the other thing that we get is that if I have made a change in product service, because it is quite loosely coupled, I can just change product service and I can roll out this change. What that means is I'll not have to test the entire solution before rolling out this change. So that means if I have automation in place, like CI/CD kind of automation, I can do frequent deployment. So this was one of our goal. We spoke about this in the beginning of the presentation that we want to do frequent deployment. So this is something that we were able to achieve. Now, because we are using REST interface over here, so our web application, mobile application, and JavaScript application, all kinds of clients can deal with this REST interface. So that is another plus. So these are the reasons why you would like to do microservices architecture. So I hope this is a compelling reason for many of the organization for adopting microservices, and they are adopting microservices for this reason. And that's why after year 2010 and to this year, and we don't know for how many more years, this will be the dominant architecture. The only downside to this architecture is that because you have lots of components, the number of components actually go up in this architecture. You have multiple databases, and you have certain other things to take care of, which we will discuss later during the presentation. Uh, and you may also have to do, you cannot do transactions across these boundaries, which is in some ways desirable, and some ways it is something that comes at a penalty because we can't do asset transaction. We will have to embrace eventual consistency, and those kind of things come into consideration. But it does give you a high amount of flexibility. If you have high amount of load, you can make extremely scalable applications, and you can deploy the fixes or upgrades every hour. So if you want to do frequent deployment and you want high scalability, this is the architecture of choice. So now next I will go to the how to develop a single microservice, and then we will see a group of microservices, how they come together, their integration. We'll try to see this in a demonstration. But now if there is any question, I would like to take that question quickly if that's possible. Otherwise, we will move on because we have
So we
quite
have
some
one
ground to
question
cover.
by Vipin Kumar. If you can share an example of ESB.
ESB, what do you mean? So you want to know what vendors are there for ESB? I think there is a MuleSoft ESB, which is an open source ESB. There is WSO2, which is again open source. And then there are lots of ESB vendors. So let's say Oracle will be there, IBM will be there. All these enterprise vendors, they are there and they have their ESB solutions that they provide and they still support. Does that answer the question?
Yes, Vipin says yes. We
Okay,
have
great.
another question by Saad Ali. How
Mhm.
microservices service discovery different from ESB?
Okay, so we will come to service discovery after a bit. So Saad, I will suggest that you wait for that. And if your question is not answered, we'll come back to that. Fair?
And lastly, we have
Okay.
a question by Abhijit that's in the chat portal. In a multi-vendor purchase scenario to make up an application,
Uh-huh.
isn't a MS architecture an overhead to manage? So many micro components from different vendors, and then a probability of conflict in resolving issues.
Okay, so let me understand this question. So he's saying in a multi-vendor purchase scenario to make up an application, isn't MS architecture an overhead? So I will say yes, microservices architecture comes with an overhead, and we will see some of those overheads. But it's not that service-oriented architecture doesn't have overheads. If you compare it with monolithic applications, there are many more overheads, but compared to service-oriented architectures, the overhead are not much, and they are worth if you have large-scale problem. But if you do not have large-scale problem, then you may like to consider SOA for the reasons we talked about. So then he is asking so many micro components from different vendors and then a probability of conflict in resolving issues. Okay, so I'll take this question. This is an important question. Uh, Saad is asking if I have many services because of microservices. So that kind of confusion comes from the name of microservices. Now, the name of microservices kind of suggests that you have lots and lots of small services. If probably we would have named it as mini services or something else, then this confusion would not have been there. But due to this microservices name, this confusion is there. Uh, Microservices doesn't suggest that you create lots and lots of small services. It suggests that you create services, loosely coupled services, where you need partitioning. So let's say along with inventory service, you have another service uh, which can work within the same domain and with the same database. Then you do not need to have a separate database for this. And maybe you can even consider it having in the uh, same service itself if it makes sense. If it makes sense to pull it out, you pull it out. And if it belongs belongs to the same domain, then even have the same database. So when we design microservices, we have to be careful. Microservices is not saying that you unnecessarily break down your services. You break it down wherever it makes sense, wherever you want to decouple services because it makes sense to decouple them, right? We want to develop services with high cohesion and loose coupling. So wherever that principle applies, make another service and have a separate database again where you will not have to do asset transaction where the domain of the problem is different. So those are the things that we can take up in any training because that's going to take time. But briefly, that is the explanation. So yes, there will be overheads, but there won't be that many overheads as you may imagine because of the name microservices. So I see there is another question. I'll take that and then I'll move to the next presentation because we have limited time. So, and if we have time late in the end, we will take any questions again. Is that fine? Let me just take up this question. How does ESB different than message broker like Kafka? So, okay. So ESB is something, let me just try to go back. Okay. So ESB has many features. If we see that not only they okay, so they can do routing of messages. This is something with message brokers routing clients will have to take care of, and consumers will have to take care of which topics they are going to read and all that kind of stuff. So their message broker is not helping you in routing. But in case of ESB, you can actually configure where a service is located. So ESB helps you in doing routing. You can write adapters in ESB, which can transform your messages. You can't do that in message queue. You can write business rules and workflows in ESB, and that's something you cannot do in message queue. For that matter, you even can't do centralized monitoring in message queue. So those are big differences uh, between ESB and message queue. So for, for that reason, in microservices, let's say we want asynchronous interaction between two services. So we can use actually Kafka-like queue or any message queue that can scale. We can use it within microservices architecture. Microservices architecture is not necessarily saying that you do not use message queue, but it is definitely saying that do not use a service component or a component like an ESB because that is going to choke you both in development and at runtime. So this will cause scalability issues both in development and during runtime. So Kafka and any other messaging queue can definitely be used in microservices, and differences we have already talked about. So now with that, I hope we understand why we are doing microservices and why microservices are getting that much of traction. Now, for developers, uh, the first thing that they want to know after knowing that this is something which is useful and how I can use that, how I can develop solution using a particular technology. So we are going to use Java Spring Boot, and we are going to see a demonstration over here as to how quickly Spring Boot microservice can be developed and it can be brought up and it can service our requests. And we will in the process also see REST interface using Swagger UI. So there are quite a few interesting things that we will see in this demonstration. So let's directly get to that. So I'm going to minimize the PPT. Let's go to IntelliJ IDEA. So IntelliJ IDEA is it's an IDE like Eclipse if you haven't used it, but it's pretty popular. So I'm going to open a project over here. This project has got a single microservice. And what microservice do we have over here? It has got a product microservice. So what I'm going to tell you over here is that how we can quickly make this microservice. I'm not going to write the code over here in order to save time. So we are directly going to look at the code. It is not huge amount of code. There is a very small amount of code that we need for this. So we will very quickly look into this. First thing that you need to create any Spring Boot project is that, especially the one which is being compiled by Maven, we need pom.xml file in which we specify dependencies. So here, the first dependency that we have specified, it is on Spring Boot Starter Web. Then the next dependency that we have is on Swagger UI and then JUnit. So this Swagger UI dependency is actually optional. Only if you want Swagger uh, UI, and I'll show you why Swagger UI is interesting. So then only we will go for this dependency. But other than that, we can just go for this Spring Boot Starter Web Artifact dependency, which is part of this parent project, Spring Framework Boot. So once we have this in place, this is pretty small pom.xml. Uh, you can get this from anywhere on the internet if you want to make microservice application. This is how it will start. So uh, this is the kind of pom.xml you will create. And then the next thing that you will create is web application. Now, this is nothing but a typical Spring Boot application where you have this main function. To start a Java application, you need a main function. And to start a Spring Boot application, you have this kind of annotation on Spring Boot application, and you extend that main class from Spring Boot Servlet Initializer, and you have this method, main method, to launch the application. So this is the minimum thing that you need to do to start the Spring Boot application. Now, the next thing that we need to do is we need to uh, create a service and we need to create its implementation. So this is the standard Spring Boot stuff so far. The next thing that we are going to do is we are going to create a product service. So this is a RESTful service. How do you create a RESTful service? You create a class. So here we have created product service class. And what is special about this class, which makes it a RESTful service, that we put this annotation at REST controller. The other special thing about this class is that we put a request mapping. What that means is any uh, HTTP request that starts with this path /products will be routed to this product service. So Spring Boot will route those requests to this product service. Now, which function will it go to uh, within this class? That will depend upon another path setting that we will do on the respective functions. So let's look at some of those functions. So here I have this function called get product, and it is mapped to this path /ID, right? So this is path param. So if you're familiar with standard REST protocol, if there is a request like /product and somebody has specified product ID, let's say product one in that, uh, because we had products over here, and this is expecting a string followed by that. So this kind of request will be actually routed to this function get product. So let's revert this back. So now we know how this routing is happening within these functions. So here we have this function get product, and its job is to take an ID uh, which will be provided by Spring Framework. This is something that we'll not have to do because our client will send this ID, and we will see that how. Once Spring Framework receives this ID, this request will be routed to get product, and this function now somehow is responsible to provide product. Now, how does it provide a product is actually an implementation detail. It's typical Java code. You can use Spring Framework extensively for your Java code, or you can just write plain Java code. I have used little bit of Spring Framework over here. I have done auto wiring of a service bean, which is just a class which has the responsibility of getting this product with so and so ID that has been supplied to us. So this will send the request to product service implementation, which will have implementation for this method get product. And this is actually going to DAO bean. So meaning it is trying to go to the database and it is trying to get this product with this ID. Now, because in this application, we do not have any database, what I've done is behind this DAO, I have provided a mock implementation of in-memory mock DAO. What this DAO does is that it has a map of products. So whatever you are asking from this service, it will come out of this map. So what we will do is first we will insert some products into this map through our REST interface using our Spring Boot service. And then once we have inserted certain products, we will try to fetch those products. So what is happening over here is we just saw three things. We uh, configured pom.xml with all the dependencies. We configured a Spring Boot application as the main class. Then we created a product service. Here we listed all the interfaces with the respective path, right? And we are going to see them through Swagger UI. There it will be much more clear. So please wait for that. And once we have created this interface, we have created this implementation, uh, which is actual business implementation. It is supposed to get products or put products in a database. And in this case, we have a mock database in form of this in memory product DAO. So this is a very simple service that we have created. Another important thing that we have created in this, an entity called product, and it has three attributes. It has an ID, it has name, and it has price. So these are the fields that our clients expect from us, and this is the data definition that we have on a service. So when we say product, this is what a product has. So this is something that information that we need to provide to our client, and there's something that we need to store in our server or service. So let's see how this works. So after you have created this kind of code, the next thing that we need to do is we need to go and compile this. And I have kept this code in this directory projects microservices. So I'm using a shell to go there. I am on Mac OS platform. If you are on Windows, a similar thing can be done through command prompt or through Explorer. You need to go to the directory where your code base is. And in my case, the code base is in single MS, which stands for single microservices. If you are getting training from us, then this is something that we provide as examples. So if you look forward to any training, this is the code that will come along with this. So I'll show you certain other things that you can expect as part of full-fledged training if you are interested in. But right now, let's just run this code. So what do we need to do? First thing we need to do, because this is a Maven project, we need to compile this. So let's first clean this. And after that, let's package all the jar files. So this will create all the jar files that will be executed as Spring Boot application. So this has generated a jar file in our target directory. And this is that jar file, product.jar. And we will make use of this. How do we make use of this? We run this service through Spring Boot run. So it is as simple as that, right? So you can do Spring Boot run, and this will start your Spring Boot application with this product service, which is a RESTful service. And because we are going to integrate it with other services later in our demonstration, this will become a microservices architecture. So right now, this is only product service. And why did this Spring Boot run could work? Because in pom.xml, we have this plugin, Spring Boot Maven plugin, which allow us to launch our jar files by using that command Spring Boot run. So this is how we have started our application. And this is not something like I mentioned earlier. There's not some REST services. They do not have interface for humans. They have because humans they generally work with browsers, right? So they RESTful services they have interface for application. So we are going to need an application to see the full interface. So what we are going to do over here is we are going to make use of a browser. What we will do is we will connect to our application, which is running on 8080, which is the default port. And then we will go to swaggerui.html. This will give us the entire interface that is being exposed by our service. From where are we getting this? We are getting this from here, from this product service. So we have defined all these interfaces. So this add product, modify product. So let's say this add product is a put request, right? So this same put request we are seeing over here. So you'll have to provide an ID over here to put a product. For getting a product, we'll have to provide the ID of the product that we are interested in. If we want all products, we can use this particular interface, get request and path products. And that is something that we have defined over here. So this is get mapping um, for get products function. So likewise, these interfaces that we have defined in product service, they are getting neatly exposed by our Spring Boot application, and our Swagger UI can show us these interfaces. And not only it can show us this, what it can do for us is we can even interact with our application. So let's open this put, right? Right now, there are no products in our application. What we will try to do is we will try to put some products. So let's try to do that. It says that if you have to put product, you will have to send the product in this particular format. So this is what we are going to use. So it can get this information from the uh, product interface that we have created. So now we are going to try it out. I'm going to click this button, try it out. And here I'm going to provide an ID. So I'm going to create a product with ID product one. And let's give it a name. So the price is 100 rupees. Now I'm going to execute this request. So where is my execute? Okay, over here. So this request got executed. How do we know that? We know this because we have got this response 200, and this is the body of the HTTP response after execution. So this is what we have got from the server, that this got executed perfectly. And this is the request that it shows us. It's the curl request using a client called curl. It's a very useful command, curl. Um, so it is available on Mac OS, Linux platform, and I'm sure there will be something like that on Windows platform as well. Let me create another shell for this. Let's call it curl. And so over here in this buffer, this is our application. And over here, if I use this command curl, see, this is going to put this product again. So I can even use this command line that this is providing. So let's just put one more product so that it becomes more interesting for us and more interactive so that we can really understand what a RESTful service is. How does it look like? So I'm going to create product 2 over here, and this is for 1,000 rupees or $1,000, whatever it is. I'm going to execute it. This request also got executed. Now, once it is executed, now we can see whether these products are there in our system or not. For that, we will go to get products. So this get products API, we have to provide this path /products, and we do not have to provide any parameters. So no parameters are required for this request. So let's try this out. Let's execute this request. After executing, we got uh, code status code as 200, and in the body we have got 2 products. So these product definition, they correspond to the product definition that we created on our server. So this is the product entity that we created, ID, name, price, and this is what we are seeing over here because we have inserted 2 products. So we are seeing 2 products over here. Likewise, if I want to get 1 product, I can do that too. In this case, I'll have to provide, no, this is put request. I'm sorry. Let's go to get request, get product. It's over here at the top. Here I'll have to provide the ID that I am interested in. Let me first hit try it out. Then let me provide the ID. So let's say we are interested in product ID 1. Let's execute this. As a response, I am getting product ID 1. I can get a similar response by using this curl utility. Curl is an HTTP client. It's like a Postman utility if you would have used it. The benefit of curl is that it is totally command line, so you can automate it. So let's say this request is there, curl, uh, this HTTP localhost 8080. And the good thing about this is that this is very transparent. You actually know what you are doing. So you are sending request to localhost at port 8080. This is your path. This is your URI. And you are telling the server that this is the kind of response that you accept, which is typical of a RESTful service. So this is the response that we will get. Now, an interesting thing that I've done over here, like I told you, that curl allows us automation. I've created this script called test.sh. In Windows, you can create test.cmd. So here, what I'm doing is I have provided this location as an environment variable or a variable that this is where my product origin is located. And here I am actually I'm just sending 2 requests for putting product 1 and product 2. In this case, let's say if I make this product, change the name of this product as 3. So now our product 2 will actually become product 3. So this just to see the difference after executing this request. Now, after that, we have this curl request for products, and then this is a curl request, HTTP request for getting just product 1. So this way we can actually automate. We can even create test by doing this automation. Let me save this file. It is saved. And now let me run this file. Let's see what do we get. So after I run this file, I can see that there was an HTTP request for which there was this response. So there was this put request and we were able to put this product. Then we were able to put another product. And in this case, this was a product 2, but with name product 3. And now when we are trying to get products, right, we are getting this response of all the products that are there in the system, product 1 and product 2. In this case, product 2 has got this name, product 3, it got overridden. And this was our last request that we made that was for single product. So this tells you a couple of things. One is this tells you how REST interface looks like. Now, if I have to give you a comparison how a REST interface looks like in comparison to SOAP interface. So let's say if you have to write a hello world interface in SOAP, this will be your request, this will be your response, and this is the kind of WSDL interface that you'll have to write. But same thing if you're doing with REST interface for hello world, this is the kind of request you will have to do using an HTTP client. So in this case, we use two HTTP clients. One was Swagger UI, we tested with that, and we tested with curl utility. And this is the request kind of request we have sent. And you get this kind of response. And we didn't have to create any interface like this. Imagine this is just the interface for what? For a hello world application. And imagine if we would have created an interface for our this RESTful application microservice that we have created just now. This interface would have been at least in 3 pages. So that's the benefit of REST. You get rid of this kind of interface that you have to do with SOAP or service-oriented architecture. You work with simple interface, and this interface can even be used by very simple client like mobile client, JavaScript client, very same way we have used it just now. So what we did just now is we created an application, a Spring Boot microservice. We can call it microservice, but technically we should call it microservice only when other services are there, the integration is present, and these services are working together. But nevertheless, it is a microservice, and we have created that. And with that, this is a good checkpoint to take questions. So if there are any questions, I can take those questions right now. Let me check if there is any. Can we have, I can see one question. Can we have a session on microservice design patterns as well? We can have sessions, but they will have to be scheduled. And that's something I'll leave it to Anamika, but certainly these things are possible. We can even have, Anamika will let you know that we can have follow-up training. This is just a webinar to expose everyone with what microservices, why do we use them, and if we have to develop them, then what does it take to develop them. Our next topic will be that if we have 2 3 services together, then how do we integrate them. And while we integrate them, we will see some patterns like gateway services, discovery services, load balancers in microservices. So those kind of patterns we will see. We will also try to do a Docker implementation of that. So we have limited time available with us for that. So if there are no questions, I will switch to that. But if there are any quick questions, I'll take them up right now. So let's see if there is any other question. Anamika, okay. Now I have opened my chat window. I'll just have some water also in the meantime. Sorry about that if that was noisy. I see, Anamika, a question from um, Saradindu.
Saradindu.
Yeah.
Yeah.
And the question is, if the client is developed using JavaScript framework, what could be the efficient approach to develop microservices with Node.js or Spring Boot? Uh, what are different processes need to be considered? Now, I would say some of these questions are really answered by what kind of skill is available. So that's one dimension to this question. The other dimension to this question is that this Node.js, if you would like to use it, you would like to use it in those architectures where there is very less processing involved, there is more communication involved. The architecture required is highly asynchronous. So it's very event driven and what services mainly do is they make calls to other services and they don't do much of processing. That's where Node.js architecture becomes quite good. And not to say that it can't do light processing, but if processing becomes very heavy, it's something that is done in your system like it is done in enterprise systems. They are very processing heavy. Node.js is not a good choice. In that case, you'll have to go ahead with languages like Java, and that's where Spring Boot is a much better choice. So, the Spring Boot can certainly work with your JavaScript client. So, let's say if you have a React JS application or Angular application, they can certainly work with Spring Boot microservices. So that's the kind of architecture I would propose. If you have compute intensive workloads, and if you do not have compute intensive workloads, then you can go ahead with uh, Node.js also. If it is high, if you demand is highly asynchronous. Otherwise, if you do not have any stringent requirements, you can choose any one of them. So uh, these are certain ways in which you can nail down the technology for your architecture. I hope that answers your question, Samal. Okay, Gunjan Tyagi has another question. If multi microservices are using same database, then is it of any use? So certainly you can get started with multi microservices using the same database, but you'll have to take care of two things over here. You'll have to very clearly know in the future, uh, will you have to scale a lot, right? Because if you have to scale a lot, you will have to partition your database in the future. So with that in mind, you'll have to develop your services that are highly decoupled, and try not to uh, one service should not try to go into other service database domain, because that will couple them through a database. So later on, when you would like to scale your architecture, you'll have lots of problems, because this is going to be a big change for you, moving from a single database architecture to a multi-database architecture. The reason is that you would be doing asset transactions across your applications. And once you move to microservices architecture, the ideal microservice architecture, where you will have separate databases, you will not be able to do asset transactions. So that will bring eventual consistency in your system, and you will have to handle that. So you will have to handle the transactions in the eventually consistent manner. So that's going to be a big change. We'll not be able to go into eventually consistent transactions over here, but I'm just letting you know that you'll have to be aware of those kind of things, and you'll have to plan for the future. But certainly you can start with uh, a single database. Nothing stops you from doing that. But if you have to scale in the near future, better start with separate databases. Okay,
So
there is okay.
there is
So
this
seems
question
like
which is pasted by Rajeshwari. That could you
Rajeshwari.
please
Okay, so I think I'll
read?
take this as the last question, because we have to cover certain patterns also. I'll
Sure.
try to rush through that, and so that we can take some more questions after that. But let's see. So let this be the last question for this session of questions. Okay. So the question is, could you please provide links to develop sample application step-by-step guide? So I think Anamika will be able to answer this questions. We do have edForce provide trainings for this. Other than this, as a developer, I'll answer you this question. You can go to the internet, you can search for it, and there will be a lot of tutorials available which will help you in developing a single microservice. You will need help in clearly understanding what you are doing and how you can do it if you are really developing code for your projects. And if you really want to learn microservices to some level of depth, that will be provided by the trainings that edForce provides. So that's something I'll leave it to Anamika. In the end, she'll let you know how those trainings go. But yes, there is nothing special about the the application that I created. What you can do is, if you have recording for this presentation, you can just look at these steps that I have explained, and you can create this microservice application as I have demonstrated over here. I hope that was helpful to whatever extent it was possible. Um, is Swagger can use with .NET microservice? So I haven't tried that. There would certainly be something that will be available for .NET. If not Swagger, you'll have to check that. I'll not be able to immediately answer that question. Some questions I can go back and come back to you. But in this case, I'll not be able to immediately answer this. Okay. So, Anamika, I do not see any questions right now because I have few more things to cover, which will make this session more useful. So I'm going to go ahead
Sure, sure.
and
Yeah.
will answer these questions later in the end. Okay. Um, so let me close our chat window. Hopefully. Okay. So I hope everyone can see my screen. So let's move to certain architectural challenges. And this is where we will discuss certain patterns. And I'll try to show you this through demonstration. I'll uh, run an application where which will make this thing clear what we are going to talk about over here right now. So let's for next 10 minutes, let's understand the challenges that are there, typical challenges that are there with microservice integration and how we can solve that through Spring Cloud. And then we will get into the demonstration. Let me see if my pen works. Okay, that works. Okay, so here we have we developed a service called product service. It was running on port 8080. Now, what I've done over here is I've demonstrated on this PPT that we will need certain other services to make a complete service, complete system. And here we have authorization service, which is running on port 8080. We will make it the very same way we have created product service. Of course, it will have implementation difference, which every service will have. Here we have order service, inventory service. Every service will have different business logic, but the way we will create them using Spring Boot uh, will be exactly the same. So this is how we can create multiple services. Once we have created them, our first challenge will be that when we have, let's say we have a web application through which we are going to interface with our services, because we cannot interface with Swagger UI or Curl UI. We have not created it for that purpose. We have created these services so that our customers can interact with these services and can do transactions. So our customers, they will be either using web interface, or they will be using some mobile application or a JavaScript application like React.js or AngularJS, whatever it is. They will need to interact with our services, and right now, they are not in a position to interact with our services because they will need to know where our services are located. So that will come through some kind of routing configuration. So if it's a web application, we can provide that configuration in our web application. This is under our control. This will run within the domain of the organization which is hosting this solution. So if I am an organization, I am hosting this solution, I'll have this web application, let's say in my cloud, and I'll do this configuration. But this is where this will become a difficult thing, because if mobile application or JavaScript application, they are running on client desktop, there the configuration will have to be downloaded and Once it is downloaded, it will be difficult to change in case I have to change this configuration. So if authorization service I want to run on port 8081 for some reason, then uh, I'll have to communicate that to my client web application. I can configure it is there in my control, but this client is not in my control. The client will have to be updated by the user, only then they will get the update. So that's one problem. And one other problem is that there is too much of configuration that client needs to know about. If I have 100 services, they need to know about 100 services. And each service, if it has got 10 instances, so that means we have 100 into 10, 1000 instances that they need to know about. So how do we do that configuration? That's a challenge. And how do we address that challenge? We address that challenge by using something which is called as gateway service. Now you can call it as a pattern, uh, gateway service pattern. It's a pretty popular pattern even in service oriented architecture and in microservice architecture. This is nothing specific to microservices. This is, we have to do this because we have multiple services. And even in SOA, we will have, in service oriented architecture, we will have multiple services. So this we will have to do in even in service oriented architecture as well. So here what we are proposing, that we will have an intermediate component where we can uh, put all the configuration, this configuration that we saw, this complex configuration, we can put all that complex configuration in our gateway service over here, which I have not shown over here, but that complex configuration will go here. What that means is that now our clients, they only need to connect to gateway service. They only need to know where gateway service is located. Because let's say uh, our client passes this URL products, right? Now this URL will be passed to our web application. Our web application will pass this URL to our gateway service. Our gateway service has this mapping that for a certain path, which service I should route this request to. So it will look at this path. And in this case, it will route this request to product service because of this path routing that it will have. There's something additional it will have. And I'll just show you that how that configuration looks like, right? So now what that means is our client only needs to know, in this case, our web application only needs to know about gateway service. Similarly, our mobile application or JavaScript application also needs to know about where our gateway service is located. And it is not very frequent that we will change gateway service, host and port, or its URL. Actually, we can give URL to our clients, and behind that we can map this. So that way all clients can connect to our gateway service. So this is a very neat solution to route our requests to our respective services. We could have used even a reverse proxy over here, right? So something like as an Nginx or Apache, which can look at this path and route the request. But we will not get certain things that this particular gateway service, Spring Boot gateway service, can provide us. And that is something like if we want to do authentication over here. So let's say we want to send request to any of the services only for authenticated clients, then we can do that authentication over here, right? We do not need to send those requests to the client. So that way we can simplify our security over here. If you want to terminate HTTPS connection to HTTP request later on, we can do that over here. If we want to centralize the logging, that what all clients are connecting to our system, what requests are coming, what uh, responses are going back, we can do that logging over here within our gateway service. That is something that will not be provided by a simple reverse proxy like Nginx or an Apache. So gateway service is a pretty neat solution. And that's why microservices use this solution. So that is how they overcome the client configuration complexity. Now, the other kind of complexity is there in our gateway service. This is again related to configuration complexity. If we go back to this configuration that I told you early on that was there with our clients, we said that that configuration has shifted to our uh, gateway service. It hasn't gone away. So we still have to deal with this complexity that if we have these hundreds of services, then we have to do this configuration. And let's say we have multiple instances of each of these services. This configuration is going to become extremely complex. This is going to be a huge configuration. Now, to maintain that kind of configuration in gateway service is such a burden that we'll have to find a solution to that. And solution to that is discovery service. So how does discovery service solve this problem? The way it works is that we have all these services. We do some code changes, and I'll show you what kind of code changes. So when these services with that code change, they come up, they know if they know through the configuration where discovery service is located, they will communicate to discovery service that look, I am authorization service. This is my service ID. And for that service ID, um, I am running at so and so host and so port because this service knows at what host and port it is running. It will tell this discovery service that, hey, I am available at this host and port. Similarly, this thing will be done by all other service. So product service, order service, inventory service, all of them will register with discovery service. Now here our client gateway service, if it has to route requests, let's say to product service, how will it know where product service is located? Because we have not done configuration over here. There is no configuration about the routing of about the endpoints of our services. What this will do is it will make a call to inventory service. It will get that information, tell me where product service is located. It will get that information because discovery service has that information. It will use that information to make a call to product service wherever it is located. Similarly, it will do for other services. So that is how we simplify our gateway service complexity. We also satisfy, simplify the complexity of other clients. So let's say order service needs to call inventory service. So how does it know where inventory service is located? It can again go back to discovery service. It can make a call to that and it can get that information. And for subsequent calls, it can use this information to make calls to inventory service. So this is how uh, this configuration information about where the endpoints are located. And for that matter, if these endpoints are healthy also, that can be reported to discovery service. And all these clients like gateway service or order service in this case can make use of this information from discovery service. So pretty useful stuff. The last pattern which will complete this and we want to talk about is that how does gateway service does the load balancing between multiple instances that are available. So similarly, how does order service when it has to make call to inventory service? In this case, we have two instances. How does it decide which instance it can make call to? So that is done through load balancers that are provided by again Spring Cloud. We get that embedded load balancer along with gateway service. But if we are making order service, this is something that we are writing. Here, this load balancer client will not be available out of the box like it is available in gateway service. Here, we'll have to do some code uh, to interact with discovery service, get the all the instances. So first thing that we will do is we will get all the service instances for inventory service. There's something that order service client will do. Then it will, among the instances that it has got from inventory service. So let's say it knows that there are instance number one and instance number two located at so and so endpoint. It will choose one of those endpoint according to load balancing strategy. And according to that strategy, it will make a call. So this is how these three important patterns will be implemented. What I will do at this point is I will quickly show you how these patterns will be implemented. I cannot show you everything right now. Webinar won't be sufficient for that, but I can give you some idea of what goes in for this. So let's say the secure MS is another project. It will look something like this, right? It has different services over here, authorization. There is a common library as well, which we can have in gateway service, which we can have in microservices if it does not create any dependency. Uh, because if it has utilities which have to be used by every service, irrespective of what service it is, we can put that in common. But we have to be careful about that. So here, let's say when we are creating gateway service, that's something we have looked at first. In gateway service, we create this kind of configuration. We create routes, right? And we let these routes know uh, where is the endpoint. And in this case, we have the endpoint we have defined as load balancer, which indicates our gateway service that the endpoint information is actually available in inventory. It is available in discovery service. So this is gateway service configuration. And with this kind of configuration, it fetches information from discovery service before it routes requests. Now, similarly, let's say in order service, we spoke about it needs to make a call to inventory service. So here we have an implementation, we have an inventory client within order service, which will make a call to inventory service. So here what we are doing is we are getting this, this is again all Spring Cloud stuff. What we are doing over here is we are providing service ID with which inventory service has registered itself with discovery service. So this here load balancer actually represents a class which can communicate. It's a Spring class which can communicate with discovery service. So we are asking this load balancer that look, you communicate with discovery service and get me one instance from the discovery service. So here, if you see this function choose, this is where load balancing is happening. So behind the scenes, what is happening is that this particular function will make a call to, so this order service will make a call to discovery service. Spring will do that for us, and it will get list of all the inventory service instances that are available. So all the inventory instances, and it will provide it to this order service load balancer that we have over here. And this load balancer will choose any instance out of that list. So we can use a random strategy or round robin strategy, and we can choose one of the instance. Once we get that instance, we can get host and port information out of that. And then we can make an HTTP call over here, like you would do with any HTTP library using um, that HTTP client. So that is how you can do, you can quickly make load balancer. And let me give you one more piece over here, that let's say if you have to make gateway service, the biggest thing that you have to do over here is that apart from certain filters which are optional over here, and I've created one filter for authentication and for logging. The main thing that you need to do is that you just need to provide this application.yaml, and this is pretty much actually that you do in terms of writing code for creating a gateway service. So right now what I'm trying to do is I'm trying to just show you how easy it is for developers to create this. So let's say I'll not go into discovery service. Let me go to order service. Let's say it has to register itself uh, with discovery service. So let's see how easy it is. So how that can be done, we will see that. So I think in the main web application, we have to just write this annotation at enable discovery client. So if we do this with any Spring Boot service, this service will actually register itself with the discovery client. And how does it know? Not with discovery client, with discovery service. In this case, this is acting as a discovery client. And how does it know where discovery is service is available? We can put that in application.properties. So here we have provided this information that this is where discovery service is located. So these are the things that we can be covered in training, but right now here I just want to give you an idea of uh, what's there in Spring Cloud Stack and how easy it is to do that. And that is one of the reason Spring Cloud Stack is immensely popular for developing microservices. Now, let me just quickly run this to give you a feel of uh, how this microservice can be easily run and how we can interact with this. And it will give you a good feel. What I'll do is I've killed the previous Spring Boot application that I have run. Now I am going into another project where I'm going to compile and package this. So this will compile all our services that are there in our system. This should be pretty quick. We'll not have to wait for this much. Right? So all these services that we saw, these microservices, they got compiled and they got packaged. Also includes discovery service. It also includes gateway service, and it has these functional services like order product we discussed earlier. Now time to launch this. I've just created a small automation so that it can launch all these services one by one. So it's just a for loop in this script, which will launch all these services like we did this launching manually last time around. When we created single microservices, we launched only one service. This time in the loop, we are launching multiple services. So we will wait for them to come up. And in the meantime, what we can do is we can go to a browser and on local host, and our registry actually is located on 8761, our discovery service. So this is where our discovery, this is now we have connected to our discovery service. And here we can see that there is authorization service registered with discovery service. For that matter, gateway service is also registered, and they have registered themselves with an ID over here. There's the ID that clients can use to locate a service, right? And here we also have host and port information as to where the host and port is located. Right now, we do not have all these services over here, but if we refresh this, by this time, all services would have registered. So if you see this, here all services are registered. Now, if we want to see the routes that are there, right? We can, in the gateway service, what we can do is we can connect to gateway service. It's running on port 8080. And I think the URL is actuator gateway routes. So there's something that Spring provides you. Anytime you are debugging, you do not know whether there are routes which are correctly configured in your gateway service. You can actually hit this URL and you can see the routes which are configured in your gateway service. Now, with this information, actually what we can do is we can actually use a curl client. I have already created an automation to actually make a call to this system. So we will go to the project, and in this case, the project was different. It was secure MS. And here I have this script called test.sh, right? Here I have provided this information where gateway service is located. That's all we need to know. Because we have authorization service also, I have provided username and password over here, which will be used by our client to fetch authorization token from our authorization service. And then subsequently, whenever we will make call, we will make similar calls that we made to product service earlier. This is exactly the same. The only difference is instead of calling product service, we will be actually routing request to gateway service, and we will also be passing authorization token because now our service is secured. It requires a token, and I'm fetching this token from authorization service, which is our microservice, and it has OAuth 2 configured in it. So I'm going to execute this. Uh, Let me also show you the window where our, so this is the window. The top window is where our logs are coming for our services. And then I'm just going to run this test client, right? The curl client that I just showed you. Now, if you see this curl client is running over here, the log we are seeing over here. And this the std out log that is coming out of our services. So we can see this, our gateway service has been called uh, with path request for inventory service. And this is the status code that we have got. And similarly, we can check the responses that we have got from our uh, curl client. If you see this, in this, we created a full-fledged order. This is a request that we have sent to our order service, and it has showed us that this is the order that got created. So this is how you get a RESTful response. And the last command that was executed over here is show me the inventory after. Okay, this is just the order. This is the last one. Show me the inventory, right? Uh, that is after creating the order. So here, if we see this, the inventory has decreased. Uh, I'll just go up. Initially, what we did is, if you look at this product, we created this product uh, with quantity 5,000 and quantity 1,000. So this was our inventory service product request. So we had 1,000 units of product one, 5,000 units of product two. And in the end, if we see that these quantities have decreased. So the point over here is that we have our integration in place. We have our system right now with these small changes. We have been able to create a system which has got a gateway service, which has got discovery service, which has got these clients, which are functional right now, and our entire microservice system is working. So this is how you create a microservice system. There are a few things, of course, you can do with this microservice system, like you can play with Docker containers over here. So what you have to do over here is I'll quickly show this and then I'll open this for questions. I can see that we are running short of time. We have 5 minutes to close this, but I'll try to show you this quickly in case you want to get a good feel of Docker. We don't have much time, but I'll show you whatever bit I can show you. So let's just go to this another project directory, uh, Docker. And here I have few files. I'll show you those files one by one. This Docker file is where we tell Docker that we want to build an image, and this image has to be on Ubuntu, and on that Ubuntu install certain tools. In this case, what tools I am most interested in? I am running commands here to install JDK, right? And then I am providing it a script to launch our service. And here is a command that I'm telling that launch this particular script, docker entry point.sh. So let's look at what is there in docker entry point.sh. Here, the important thing apart from some argument validation this script is doing is it is launching our Spring Boot application directly using the jar file. So we are not using Maven Spring Boot command over here. We are directly using java -jar command, and we are providing this what service we have to use as an argument to this particular script. And this argument will come from environment variables, and we will see that this docker.env file, it has got these environment variables. All the environment variables which are common to our services, these environment variables are common to all our services. So let's say this is discovery service, where discovery service is located, or what logging we have to do. That is common across all our services. So we have provided that kind of information over here. Then the last thing that we need to get Docker running is Docker Compose. So if you have to do this on your own, then no need to be scared of this. This stuff is simple and can be done very easily. So this is where we have created discovery service container. And this is where we have created gateway service container. I'll just quickly tell you what it is. Here we have using the image that we have created in Docker file, the first file that we saw. Then we have the port information we have told on which port this particular container, this particular Docker container should run. What is the name of Docker environment variable? And then certain environment variables, if you want to override from that env file, we can specify them over here. And then we are telling this image that from this hard disk, pick up this gateway.jar, because we have not put this gateway.jar in the image, Docker image that we have created. We are telling it to pick it up from our hard disk, in this case, hard disk of my machine. And this is what I've done everywhere. This is so Docker file tells, so I'll just give you a revision over here, a quick revision. Docker file tells you how to create Docker image. Docker entry point.sh tells you what to execute. Docker.env tells you what are the environment variables of your service that you are going to run in Docker container. And Docker Compose is the file which will bring it all together. We will use it to use these commands like dc up -d. It will start all our containers. So now all our services will run in containers. There is a slight problem over here. The problem is that I have not stopped my previous containers, not containers, the services that were running on our machine. So hopefully nothing is running. I think I'll have to kill them manually now. Just 1 second. $1925, that needs to be killed. Then 1880. I think these are not getting killed. Seems like they are gone. So okay, so no need to kill them. Let's just start our command once again. Okay, let's do this all over again. Okay, I'm in the wrong directory right now. So let me go to Docker directory. In this Docker directory, the files that are required for launching the images are there in jar directory. So they are not there right now. Let me just copy them over here. Now they are there in this jar directory. Okay, so now our Docker containers can make use of this particular uh, jar files. And if I look at Docker images, there are, okay, so let me just launch it. I think we do not have too much of time. So if we can show this, I'll just show you this, that these Docker containers are launched. And if we want to see this, this Docker Compose, actually the DC is an alias for Docker Compose. Command is actually Docker Compose. These services are running right now. And if I want to connect to our services the way we did last time around, so let's say we did use this curl utility, test.sh, we can do it right now here also. So empty reply from server. I think there is some issue right now with this. So what I'm going to do is instead of consuming more time over here, because there's no point in rushing through this, this was something optional that I wanted to show over here. We are largely done with what we wanted to achieve in this webinar. We have run out of time. So we can do this later at an appropriate time. So what I'm going to do is I'm going to close this and open for any questions. But before that, what I'll do is I'll just uh, summarize this. What we have seen in this particular presentation is uh, why we got answer to this question, that in which case we use microservice, where SOA is a useful architecture where monolithic applications can be used. And if we have to make microservices, how we can go about doing that. Certainly, not everything can be covered in this webinar, but that's something for the future. So now I'll open this for questions. If we have time, we can take questions, Anamika.
Yeah,
Otherwise,
there are few questions which came in. Not sure if you have already answered them. One
okay.
was from Abhijit, the other one was from, I guess,
Okay, so
Gunjan.
I'll look at my two windows that I have. Hope you have shared. Okay. This is Gunjan Tyagi. Okay, I think we are done with that question.
Okay.
Rajeshwari, there is one question. Could you please provide links to develop sample application? I think I answered that
Yeah, yeah.
question. Then Daniel, a question from Daniel. If discovery service is taking care of all config, then what is the need of a gateway service? Okay, I'll answer that question. So discovery service is not for routing requests. If you see this, I think I'll just go to that. Right, somewhere we have this. Yeah. So I don't know, I have chat windows in front of me, but probably you people can see this. This gateway service, just a second, let me, yeah, this is a better diagram. So over here, yeah. So gateway service, any request that will come to the gateway service, it will be routed by gateway service. It will not be routed by discovery service. Any request that is coming to gateway service is being routed by gateway service. Discovery service does not have that capability. The capability that discovery service has is that it knows where other services are located. So any service request that comes to gateway service, it will go to discovery service, and from here it will know where the service is located, and then it will route the request. So notice routing capabilities are there in gateway service, and where service information is located, that configuration information is there in discovery service. So I hope that that answers the question. So I see there is another question. Is gateway pattern same as proxy pattern? In many ways, it is same as a proxy pattern, Varun. The only difference over here is, like I mentioned, in gateway service, you can do additional things, right? You can do authentication over here, a central authentication if it makes sense, right? And which is a general thing which these days people do in gateway services. You can log requests. You can get a view of what all requests are coming to your system. In case you want to drop certain requests, you can do all that stuff over here. Bottom line is you can write custom code in gateway services, which you will not be able to do in a typical reverse proxy that follows just proxy pattern. So let's say if you take Nginx reverse proxy, which is a load balancer, you can do very limited stuff. But in gateway service, because you can write code, you can do a lot more stuff. So I hope, Varun, that answers your question. Any other question?
Yeah, there is one by Anup. Can we use discovery service in prod level applications? That's, I guess we'll take this as a last question then, and probably will wind up.
Okay. So the last question over here is, can we use discovery service in production level applications? Yes, you can use discovery service in production level application. If you see this, this discovery service used by over here is Eureka service. This has come out of Netflix. So Netflix is actually using this discovery service and gateway service. This is the architecture uh, which Spring Cloud supports right now. It actually came from Netflix project only, and Netflix is very much using it. And because it is an open source, many other organizations are using this architecture. There is a small variation to this. Kubernetes does not need a discovery service. It provides a DNS. So there it becomes redundant. So there we can deviate from this architecture a bit. But if we are doing Spring Cloud and we are not doing Kubernetes and we are doing an architecture like Netflix or let's say Amazon, then this is something that that is still applicable. I think that was the question, and I hope I have answered that question. Yes, it is used in production. That's the short answer. So Anamika, with that, I am done. So now I'll hand it over to you. So if there are anything related to trainings, you can take care of that. And I want to thank everyone for being a very good and patient audience. Thank you very much.
So sure, I'll be quickly sharing my screen. So let me know if that's visible. Is it?
Yeah, Anamika, I can see your screen.
So everyone who were asking about the sessions on the microservices, so edForce is planning for an upcoming training from 10th to 13th of May. It's a 4 half-day session on developing microservices with Spring Boot that will be delivered by Sir himself. So anyone who's interested in it, please, you can definitely visit our website, or I'll just paste the link in our chat box. And apart from that, for any queries, do let us know. The recordings, as I have already mentioned quite some times, that we will be sharing with you right after the completion of this session, or maybe by EOD or tomorrow. And there is a survey link which I've also pasted. So feel free to share your feedback. I and Sir both will be happy to collect your thoughts about the webinar. And yeah, as I would lastly like to thank Sir for the session, because it was quite informative and interactive at the same time. So thanks a lot for your time today.
Thank you, Anamika.
I believe, yeah, we don't have any other questions. So yeah, we'll conclude the session here. Thank you, everyone. Have a great evening ahead. Thank you, Sir, again.
Thank you, everyone.